Good morning, everyone. So last class, you watched a video that kind of overviewed everything we're going to learn on exponentials. So today we're really going to focus on one part, which is exponential functions in terms of growth and decay. So when you do this, so pretty much what we're going to decide with these over here are whether they are growth or decay. And what you always look at is you're always going to look at the number in the parentheses. So I'm going to highlight each of them. So you're always looking at that number in the parentheses. If that number is greater than 1, it's going to be growth. If it's less than 1, it's going to be decay. So here, is this less than 1 or greater than 1? It's greater than 1, so it's growth. This is greater than 1 or less than 1? It is less than 1, so it is decay. Same thing here, 1.02, is that greater or less than 1? It is greater, so it is growth. And now these, if you need to, put them into decimal form. So 3/4 is 0.75. So is that greater than or less than 1? It is less than 1, so it's decay. I must do D for decay. Same thing here. If I do 3 divided by 2, I'm going to get 1.5. Is that greater than or less than 1? It is greater than, so it is growth. So you're always just looking at that number inside the parentheses to decide whether it's growth or decay. And if you ever have a fraction, you can always put it into a decimal form. The initial amount, so that's going to be our yellow, our initial amount is the number in front. So it's kind of easier to see it in those. So we have 9.8, that's the number in front, 5, 7, and 27. It's the number in front of the parentheses. If you don't have a number in front, it's just a 1, since you have one of those. Your growth rate, all you have to do is do 1 minus your rate. So here I'm going to do 1.35 minus 1 to get 0.35. And in this case, I actually did r minus 1. That's because your rate will never be negative. If it's negative, it would be a decay factor, and it would just say the decay rate of 35%. So in this case, I'm going to do 1 minus 0.35, which would be 0.65. And again, you can make this a percentage by moving the decimal 2 to the right. Over here, 1.02 minus 1, which would be 0.02. 0.75, again, don't use decimals in this case. You want to use your, don't use fractions in this case. You do want to use your decimals. So 1 minus 0.75 should be 0.25. And same thing here, 1.5 minus 1, which would be 0.5 or 50%. So it can be written as a decimal or percentage. It's totally up to you. Your growth factor is the entire yellow thing. So 1.35. The entire thing in the parentheses. That is your growth or decay factor. So 1.35, 0.35, 1.02, 3/4 or 0.75, and 3/2. Okay. If you have any questions, please let me know. Again, we are going to Zoom after this today at the last 20 minutes of class, like our usual session. We talked about this last time. Determine which of the following sets of ratios shows exponential behavior. That means you're multiplying each time. You're multiplying by a common ratio. To do this, all you do is you look at the y values and you try to find a common ratio. You are seeing, are they multiplying or adding every single time? Well, here, I know 0, 2, 2, 4, 4, 6. That's adding 2 each time. So this is no. This is a linear function, because you're adding every time. You're plusing 2 each time. In this case, well, again, I'm going to highlight the y's because that's all I'm caring about right now. You really don't care about the x's when you come to exponential behavior. How does 1 become 4? Well, I could add 3, but 4, it doesn't, if you added 3, you wouldn't get 16. So I know, though, how does 1 become 4? You're multiplying by 4, multiply by 4, multiply by 4. The other way to do this is to do second term divided by first term. So 4 divided by 1, and you get 4. And you just see if you're multiplying by that number every time, which you are. So this would be yes, you're timesing 4, or 4 is common ratio. That is the number being multiplied each time. My video